Hello and welcome to Computer Concepts, Module 4, Operating System and File Management. This is part 1 of a multi-series video on operating system and file management. Overall, in this lesson, we're going to cover pros and cons of different types of operating systems, how an operating system works, how we personalize the operating system to better meet our productivity needs, and then finally, how we manage files and folders. For this section, the outcomes are I'll demonstrate the differences between operating systems and system software, explain the differences between the major operating systems, identify specific desktop components that are unique to primarily client operating systems. So as we look at this, the differences, first of all, are, what computer it runs on, what hardware. We've talked in previous videos in regards to processors, memory, etc. And different operating systems are going to use different resources, meaning the old Apple Mac operating system required a proprietary CPU in order to run. Now they've since switched to a standardized Intel CPU, Intel chip format, which means it will run on Intel chips. However, now they're going back to manufacturing their own proprietary CPU. So you want to make sure, that you're meeting the hardware needs of the operating system you choose. Now, here on the right, I've given you 3 of the primary operating systems for client, which means desktop, laptop, what you're used to using as an end user system. At the top right in blue is going to be the Mac operating system. Of course, this is Windows based. It is proprietary, meaning that they have license over it. You must buy a license to use it. Then there's Linux Mint. Linux is an open source. Unix, Linux, you've probably heard those terms. Those are open source. That means there's an entire community that programs the operating system. Now what happens is communities will get formed like the community that runs Linux Mint, and they'll specialize in creating an operating system from the Linux kernel that you can run. So an example here is Linux Mint. Another might be Ubuntu or Ubuntu, depending on how you say it, etc. And then, of course, you're probably familiar with Windows 10, which is manufactured by or programmed by Microsoft Corporation, and that's down here at the bottom. I'm giving you an example of a Windows 10 operating system. We're looking at the desktops of these different operating systems. Now, what do we do with an operating system? Well, as mentioned in a previous video, this is the first piece of software. Well, let me be careful here. This is the first piece of software that we're installing, but realize that in our system is a ROM chip that holds the BIOS, the basic input operating system. It is what runs to allow us to load the operating system software that we want to use from our computer through the processor into the memory so that we can use it. Okay, so what we can do with these, shut down a computer or device, with the operating system, we can manage programs, who can use what program, how that program is run. So maybe there are certain programs that need to be run with administrative levels. Okay, that can be risky from a security standpoint, but we can right click and say run as administrator or configure it to always run with higher level privileges. Okay. We can manage memory, we can coordinate tasks. By coordinating tasks, realize we can also remove software we're not using. We can remove services that we're not using or close services so that the limited resources we have on our computer can be utilized to maximize performance as we use it. So for example, as I'm recording this video, I go ahead and shut off things that I don't need right now so that all the system resources can go to that. Once I'm done recording, I then go in and do post-production, where if I make a mistake that I want to get rid of, I'll remove the audio, remove that portion of the video, sync it together, and then finally I'll produce it and stick it up to YouTube, for example. Or it might just be a video for my class specifically. So I can do those kind of things as well. I can monitor performance, so I can see what's going on. So If my computer seems to be running really slow, what I might do is go out and look at the network performance and see how much data is transferring from my computer maybe out to the network or out to the internet. So by doing that, I could see if maybe there's a virus or something that is, or spyware that is using my system resources. Maybe a bot. We'll talk about bots in later lectures. But a bot is basically a programmable robot where I accidentally put it on my system. It's part of a botnet, and it is constantly sending information out or using my computer to process things that I'm unaware of. Provide file management. Of course, as we start putting everything onto the computer, we've got to be able to find that 6th grade picture of our son or daughter, upon command when we're thinking about it. If it's National Daughters Day, for example, and we want to post a picture, we've got to be able to find the files. We've got to be able to find Word files, Excel files that relate to clients, that relate to the work we're doing, and do it quickly. So it's imperative that we create a good file structure as we do this. We can update the operating system, so if there's security flaws, it can be updated. We can look at monitoring security, and then of course, controlling network access. Maybe there's a computer that we don't want to actually put on the internet. Now let me go back here real quick. You notice here I give you an example of what the operating system or the system functionalities are for Mac, system functionalities for Linux Mint, and system functionalities for Windows. Moving on, so operating system features. Normally today, there's 2 types of operating system controls. Now, what we're used to back when computers first came out, all of their operating systems were what was called command line interface. And the cool thing about command line interface was that we didn't have the extensive processing power in order to manage a graphical user interface. So I've read that upwards of 60 to 70% of the resources of a computer go to producing the graphical user interface. Now, of course, that makes it easier for end users because they can just click and go versus having to go in and type a command to open up a program. Okay, so examples of this real quick. So here, down here in the right, this is a graphical user interface for Windows 10. And up here is a command line interface, okay, for a Linux operating system. So although, and we'll talk about this, Linux does come with graphical user interfaces on the client side, a lot of times it's much more efficient to get rid of this processing power and use it for whatever task the computer's going to run instead of a graphical user interface. Now, what that means is we have to learn commands on how to do things, including how to connect it to the internet via a command line interface. Also today, there's the opportunity for software as a service. Now, I'll give you an example down here. If you notice, this is representing the cloud, and these are different devices. Now, the cool thing with software as a service is if it's programmed correctly, it's going to use an internet browser, that you're going to interact with the browser in order to manage the software. Let me give you an example of this. Some of you may be familiar with QuickBooks. Well, QuickBooks is actually an accounting software that started out with you bought it, you installed it on your computer. Now you can get QuickBooks where your files, your data is stored in the cloud, and QuickBooks becomes responsible for it. But the cool thing is now if I'm on my smartphone, I need to enter something in my QuickBooks and I'm connected to the internet, I can do it. I don't have to be on the computer that's hosting that particular version of QuickBooks. We've got a ton of software as a service now. We've talked about storage as a service, email as a service. Some of you are probably familiar with Outlook Web Access. That means your employer or your college is no longer running an email server locally. They're using Microsoft's Office 365 as a service. Now, finally, there's open and cloud source. The idea behind this is that we can put up our own servers to do things, meaning in Microsoft Azure, which is their cloud environment, I can put up a server to do something in the cloud that anyone can access or that limited people can access. Even though it's in the cloud, realize I can configure it to where only people in my network are able to get out to that cloud resource and use it. So we see a lot of this with email. We definitely, it's been the standard for web pages for decades now, where a web server, usually Unix, is programmed. The Unix operating system is installed on a server. The developer develops the website and everybody is able to access it. And the cool thing is, there tends not to be a great cost with that, versus when you're doing Azure, when you're doing Amazon, you're paying for the licensing of the operating systems if you're installing operating systems that indeed need to be licensed. Now, some quick examples of some client operating systems. These are the standard ones that we see today, including I threw in a Linux that you may not be familiar with. So Windows, I've already said, it's Microsoft product. Windows 10 is a current OS, and it is a client OS. OS means operating system. So it is the operating system we would find on our desktops or our all-in-ones or whatever. Mac OS, you're probably familiar with it. So on MacBooks and etc., it's the OS. It's Apple. Oh, by the way, Windows, proprietary. Okay, I can't run it for free. Windows programs it. I got to pay for it. Mac, proprietary by Apple. Okay, even more proprietary because I can actually buy Windows operating system and put it on an independent computer, where with the Mac OS, I'm going to have to buy an Apple Mac computer to run the Mac OS on. Mojave is the latest. It again is a client. You're probably not familiar with Unix. Unix is an open sourced OS. CDE is an example of a client. You see that down in the bottom right. If you notice, I color coded these and the circles match, so you can kind of get an idea of what the interface, the user interface, looks like for these. Now, Linux, I had a little fun here. Most of you are probably familiar with Mint. You're probably familiar with Ubuntu, but you're probably not familiar with Kali. Kali Linux is what's called the hacker distribution of Linux. And what that means is that there's actually a group who programs this, who adds hacker tools to the Linux, to the base core Linux operating system. Now let's be clear here. This can be used both for good and bad. I use it for good. It allows me to test networks, to see where they're vulnerable, to close things down before the hackers use Kali to do the same work, to get in to do some malicious activity. Then we're sitting here at Chrome OS. Now with Chrome OS, that's going to be our Google operating system. Okay, and with that, the current version, I'm pretty sure, is OS 71 as I make this. Now we're starting to see Chrome OS become really popular, and the reason for that is that Google is producing, and so are other companies, the Chromebook. So consequently, Windows and Chrome we can buy from many manufacturers of the hardware who are using one or both of those operating systems as the operating system for their computers that you're purchasing, where again, Mac and Apple are not. Okay, so we're going to stop there with part 1. We're going to call this part 1A, looking at the time, and I will make a part 1B. Take care.